Hello everyone, I'm Joanna Lalibo and I will be teaching you basic science. The theme for our class today is view and energy, and our topic is forces part 2. At the end of this lesson, I expect that you should be able to explain the different types of forces, explain how forces can be used or applied, and explain friction, state its uses, advantages and disadvantages. Force, as we learned in our previous class, can simply be defined as a push or pull interaction on an object or a body. This force may cause a change in the shape, speed, or direction of the object. Force can be exerted from different types of materials and during different kinds of interaction between two objects. Based on their interactions, we can see that some require direct contact between the objects and are therefore called contact forces, while some others do not require direct contact between the objects and are called non-contact forces. In our previous class, we learned that forces can be defined as a push or pull interaction between two objects or between a body, a person, or an object. We also learned that when force is applied on an object, it can bring about different changes, which include a change in the shape, a change in speed, or a change in the direction of the object when it is moving. We also learned that forces can be divided into two categories, which are contact force and non-contact or action at a distance force. The contact forces require a physical or direct contact between the two objects for the force to be applied, while the non-contact or action at a distance force do not require physical or direct contact between the two objects. In our previous class, we also learned that there are different types of forces that can be grouped under the contact and non-contact forces. Some examples of the contact forces are normal force, applied force, tension force, spring force, air resistance force, and frictional force. We will be learning about these different forces one after the other. The normal force is a force resulting from an interaction between an unstable object, that is the object that makes contact, and a stable object, which is the object at rest. This force is the force that prevents an object from falling. For example, a person standing on the floor or a cup of coffee on a table. The normal force is a force resulting from an interaction between an unstable object, that is, an object which is in motion, and an object which is stable or at rest. For example, a person standing on the floor or resting on the wall, or a cup of coffee resting on a table. Now, the wall and the table exert an upward force to support the weight of the person or the cup of coffee. The second type of force we'll be discussing today is the applied force. It is a force exerted from a person or an object to another object. For example, a person pushing a desk from one point to another, or a person pulling a bag of rice. We can see from the image that this man is pulling a brick to himself, and we can call that applied force. He's applying force on the object. Or a person pushing a table. We can say the man is applying force on the table. This is called applied force. The next type of force we'll be looking at today is the spring force. A spring force is exerted by a spring. And a spring is a metal elastic device that returns to its original form when stretched or compressed. The spring force is a force exerted upon an object by a spring it is attached to when the spring is compressed or stretched. When an object is attached to a spring, the spring exerts a force on the object which causes the spring to stretch or be compressed. That is called spring force. A spring force makes a spring return to its original state when it is released from a state of being stretched or compressed. After the object is stretched or compressed, a spring will always return to its original state. It is the spring force that causes the spring to go back to its original state after it is compressed or stretched by an object. Now, when a spring is stretched, the spring force is said to be attractive. And when it is compressed, it is said to be repulsive. Spring forces can be seen in devices like the trampoline or a diving board. As you can see in the image, when a person jumps on a trampoline board, the trampoline goes down and it also returns back to its original state by the action of the spring force. And when a person jumps on a diving board, the board stretches down and goes back to its original state or shape by the action of the spring force. The next one is the tensional force. This is a pull force exerted on a rope, a string, a cable, or wire when it is pulled on opposite ends by objects. The force moves along the length of the wire. This can be seen in the game of tug of war when two teams are pulling on a rope. The force that is exerted on the rope is referred to as tensional force. It can also be seen in a man pulling a rope wrapped around a large brick or a girl pulling a rope tied to a bucket with water from a well. The next force we'll be looking at today is the frictional force. Before we go into frictional force, we have to understand what friction means. Now, friction can simply be defined as the force that opposes movement when two objects are in contact with each other. For example, when you push an object across a table, it slides across the table and begins to slow down until it stops. The force responsible for that stop in motion is called frictional force. The friction stops the movement of the book across the table. The force that resists motion is called frictional force. Now, this force increases when the surface of the objects in contact are rough. Frictional force can be divided into two. The first is the static frictional force and the sliding or kinetic frictional force. The static frictional force is the force that stops or prevents sliding between two surfaces in contact. It is the force that pushes you forward when you run. As you can see in the diagram, the static frictional force is responsible for pushing you forward when you run. You apply your force backwards against the ground, and the ground applies a static frictional force forward against you, which causes you to move forward. Without friction between our feet and the ground, we would not be able to push ourselves forward when running. Static friction helps our legs to stick to the ground, pushing backwards. This causes the ground to push forward against our feet, thus stopping us from slipping or sliding. The second type of frictional force is the sliding or kinetic frictional force. The sliding frictional force is the force that causes one to slide backward or forward when pushed or in a steep environment. This force is experienced when a truck is being pushed by a sumo wrestler or when a couch is sliding against a steep surface. As you can see in this diagram, the ground is steep, which causes the board to slide downwards. The force responsible for this sliding action is the sliding or kinetic frictional force. Now, we're going to look at the advantages of friction to us. Friction is used for movements like walking and driving. As we learned, the static friction is what aids us to move and causes us not to slip on the ground. Friction also helps us have a firm grip when we hold objects. It also produces heat, which is used to start fires for cooking and other activities. In rural areas where gravels are used to start or light fires, the friction between the two stones produces heat, which causes the fire to ignite. Friction also causes a person moving to slow down or gradually come to a stop. These are some of the advantages of friction to us. Frictional force increases when the surfaces of the object in contact are rough, because the rough surface makes movement harder. For example, when we compare a girl running on a grassy field to a boy walking on a snow, we notice that the girl running on the field moves with more difficulty because of the grasses, which makes the surface rough, while the boy walking on the snow moves easier because of the snow, which is smoother. Now, frictional force increases when the surfaces of the object in contact are rough. That is, movement is more difficult on rough surfaces than on smooth surfaces. So friction can be observed more on a rough surface than on a smooth surface. Friction is very necessary for movement and in other activities in our day-to-day lives. However, it can also cause problems as it makes movement difficult. Some disadvantages of friction include the following. Friction increases wear and tear of objects, especially on moving parts of a vehicle. Friction makes movement of objects like big machines difficult, which causes it to use more fuel. And also, friction also causes increased spending on lubricants that aid movement in areas that are rough. Friction causes difficulty in movement on rough surfaces. Therefore, lubricants have to be applied on such areas to aid movement. The purchase of these lubricants leads to more and more expenses. The next kind of force we'll be looking at is the air resistance force. This is a special form of frictional force that resists motion of objects in air. For example, aeroplanes, cars, arrows, and many others. Air resistance force is more when the object moves faster, and it is less when the object moves slower. Now we're going to look at the different types of non-contact forces. As we said earlier, non-contact forces are forces that do not require a direct or physical contact between two objects. Some examples of these forces are gravitational force, electrical force, and magnetic force. The gravitational force is the force which attracts objects towards the earth or moon. This force, which we also call force of gravity, makes every object on earth stay on the ground. The action of this force is seen when one jumps or throws a ball in the air. Now, as you can see in the diagram, when a boy jumps into the air, he definitely comes down to the ground. The force responsible for this is the force of gravity or gravitational force. The gravitational force is directed towards the center of the earth. All objects on earth that have mass experience this force. The force of gravity is always equal to the weight of the object. Therefore, when the mass of the object is bigger and closer to the ground, the gravitational force increases. We can see or we can observe that the two objects do not have to be in contact for this force to take place. When a person jumps into the air, there's no direct contact between the person and the ground, but the gravitational force still takes place, which causes him to come down. The next example of non-contact force we'll be looking at today is the magnetic force. It is a push or pull interaction between two objects brought about by a magnet. This force of attraction that causes an object to pull towards a magnet is called magnetism. All magnets are made up of north and south poles. This force is the attraction or repulsion that arises between electrically charged particles due to their motion. Magnets attract objects like ions, ion filings, nails, and other metals. The third non-contact force is the electrical force, and it is a fundamental force of nature. It is the force that exists between charged particles, and the two different charges are the positive and negative charge. These charges interact with each other by causing unlike charges to exert a force of attraction on each other and a force of repulsion on like charges. These charges are present all around us. Now, the positive and negative charge exert a force of attraction to each other, while the like charges, which could be positive and positive or negative and negative, exert a force of repulsion to each other. Electric force is what makes our head stand on a cold day, and it also causes a dark room to be bright when a lamp is turned on. In summary, we have learned that there are different types of forces that act in different ways. We also learned that some forces require direct contact between the objects, for example, frictional force, while some other forces do not require direct contact, for example, the magnetic force. We also learned that friction is what helps us to move, run, drive, and hold objects. We're going to take a few questions to see how well you have understood this lesson. The first question, action at a distance force is also known as A, contact force, B, non-contact force, C, air resistance force, D, action force. The correct answer is non-contact force because the force acts on the objects while they are not together. That is why they are called action at a distance force. The second question, which of these statements is true about friction? A, friction is a non-contact force. B, friction can be beneficial. C, friction does not involve movement. D, friction is a magnetic force. The correct answer is B, friction is beneficial to us. It is what helps us to move, run, drive, and hold objects. I hope you enjoyed the lesson. See you next time.